And what do we need all of this for? And like I said, it all comes back down to the fundamental theorem of algebra from Carl Friedrich Gauss, where he said if it has an x to the first in it or higher power, it has a solution. And mathematicians went crazy trying to find them all. And that's what algebra is. It's all the development of how do we find all of these solutions and all of these answers. So we talked yesterday about how the fundamental theorem of algebra tells us the degree indicates how many solutions this should have. So this one should have four total roots. But we also said we have learned to find them all by factoring if possible. And if we couldn't factor it, we used the graphing calculator to get it down to where we either could factor or use the quadratic formula. So if we factored x to the fourth minus 1, we had x squared minus 1 and x squared plus 1, and would realize that x squared minus 1 was still factorable because it was a difference of 2 squares. So very quickly we had our nice 2 real solutions of -1 and 1. But then we also had 2 imaginary solutions. And those are the ones we're not concerning ourselves with in Chapter 6, because Chapter 6 is about the real roots. So we would be interested in the -1 and the 1 as the 2 real roots. Which means, if we went back and saw this problem now for this chapter, we could add 1 to both sides and take the 4th root, because we're not concerned with those imaginary solutions anymore. We just need to undo it and realize, hey, this is an even root. I'm going to get the plus or minus 1. So by solving, we're getting the real solutions. With factoring, hopefully we can get it down to a quadratic where we can find all of them. So our focus, real roots only. And we had started on some of these, and we're still doing the same thinking that we had before, which is we have 3 slots that need to be filled with the exact same number in the hopes of getting -8. And that was -2, because that is the only number that was going to do that. Got over here to B and said, all right, well, a little tougher, have a decimal, but just think of it as a 4 to start with, and you realize you're going to have to put a 2 in here. And then you think, for each multiplication, the decimal place is going to move over 1 position, because we have 2 decimal places in this problem. 1, 2. Well, it has to be equal between all the numbers, so there'd have to be 1 decimal place in each of these. That way you don't have to use a calculator whenever you get to decimals. And then we talked about C, and we said, trick question, 4th root, negative number, no real solutions. D, kind of a trick question. Here's why. We look at this and we say, well, if there's no index there, it's because of 2. And square root and squaring something are supposed to undo each other. Hey, the answer is -2. But that's not the answer, because we also have to follow the order of operations. And square root symbols are just like parentheses. They're grouping symbols. That's what they are. So we have to do the math that's under it first and say -2 times -2 would give us +4, and then take the square root. So we have a plus and minus 2 right there. So anybody have any issues with that stuff from yesterday? This was kind of the stumper. Is this one sitting well with you now? You realize why things are working the way they are? Well, good, because what I would like to do then is have you work on the got it here for number 2. And I'm going to do the candy partners for the first time. So those of you that had me first semester, hang on. Remember that not everybody would. You can already tell me what the answers are. Everybody can say it, right?
-3.
-3.
I didn't
What's
say
B?
anything because
No
I wanted a
real-
candy partner.
Exactly. No real solutions. How about C?
Plus or minus 7.
Good. Because we'd have to do the square root of 49 and then square root of -49. Plus or minus 7i. No.
No
Well,
real.
we're only doing
No.
real. It says real.
No. Solutions. Exactly. So it's hard to forget what we already know. I don't want you to forget what we already know. What we have to focus on is, in this chapter, it's the real solutions that we care about. That's what we want. So off we go. Gotta get a little harder. Has to, a little bit. So now what we see here is, looking at part C of the got it problem, we see that if n is even, then the nth root of a to the n is positive, even if a itself is negative. What on earth are they talking about? Part C. Yeah, that's the one. That's the one where we have to think, wait a minute, I have to do the math that's under there first before I take the square root. So a quick reminder there that this isn't simplified yet. If we're going to do our square roots, our cube roots, our fourth roots, what's underneath that radical symbol has to be in simplest form. So the radicand has to be in simplest form. So that's what little reminder is here. Now, when does this get a little tougher? We haven't been doing algebra. Yesterday we didn't do algebra. You see any x's and y's in anything we did yesterday? No, they're all numbers. So now we have to introduce what happens if we don't know what numbers people are going to put in. What if we have a's and b's and x's and y's? How are we going to make this work? And that brings up this point, which says for any real number, a, when we find the nth root of a, if this is an odd index, we're getting one answer. We're going to. So we just get one answer back. We get that a, whatever it is. But if that number is an even root, and we have an a down here to the nth power, we're going to have to use the absolute value symbols. Now that doesn't make any sense. What do we need those absolute value symbols for? Let me show you. Oh, I better give you one that probably doesn't work out quite as nice. The square root of x to the fifth. So when the person wrote this problem, this is all about the author's intent, they knew that we were only going to put positive numbers in here to get an answer. How did they know that? Because if we put negatives in here, we wouldn't be able to do this problem. We would get no real solutions. So in this case, if we're going to take the square root of x to the fifth, and our answer comes out with something that would be negative, we have to tell people, we can't use negatives in this. The person that wrote this knew we weren't going to use negatives. So what's going to happen here is we're going to talk through this two ways. I'm going to give you the short and sweet, and I'm also going to talk you through thinking about this in terms of if you wrote this problem, what did you want to happen? And both of those ways will get us where we need to go. So remember this rule. Watch closely when the radicand contains a variable. That's when we have to start thinking about, does this need absolute value bars? You must include the absolute value when n is even. So index is even. And omit it when n is odd. If your index is even, but your answer comes out as an odd power, that's when you're going to need absolute value bars. Index is even. Answer is odd. We're going to need absolute value bars. Now let me go back to my basic example up here and show you why this is going to work. If we have the square root of x to the fifth, and we want to undo that, we'd want to have the square root of x squared, the square root of x squared, and the square root of x to the first. Now it's been a while since we had to work with radicals, but remember, radicals can be multiplied by other radicals. It's not a problem. So I look at this and I think, well, these two are undoing each other. That's just going to be what happens. So this will be an x, and this will be an x. But the square root of x to the first, if I don't know what the number is, I don't know what to do with that. So that's going to be the square root of x. I have x squared square roots of x. And I'm trying to figure out, should I put absolute value bars on this thing? Is there any chance that no matter what number somebody puts in for x, just in the front here, that this is going to come out to be negative. There's absolutely no chance. I don't need absolute value bars. So that's the reason that if we have an index that's even and we end up with an answer that has an odd power, we have to throw those absolute value bars on there because that says, hey, originally they were forcing us to just put positive numbers in here when they wrote this formula. That's the only way this is going to work. So at the end, we have to warn people, only positives, everybody. Don't use this formula unless you're using positives. That's what's going to work. So down here, problem 3 says we're going to simplify radical expressions. We're going to do the simplifying just like we've done before, which means we're going to separate this and say, that wasn't too tough. I liked doing that. The square root of 16, it's all good. But now I have the square root of x to the 8th. Okay, well I'm going to need to break that up into x squareds. So take a peek at what I'm doing. X squared times x squared times x squared. I do it 4 times. 2 plus 2 plus 2 plus 2. That's our 8. And radicals can only be multiplied by other radicals. So if we multiplied these back together, we would get the square root of x to the 8th. Now, square root of 16, we talked about this yesterday. When the book only gives us the square root, we don't have to physically take the square root to solve. That means they only want the principal root. So we're not going to do the plus or minus piece. We're just going to put 4 for that. The square root was already written for us. We didn't write it, so we don't need to do the plus or minus. That's the principal root. And then I realized, well, these are all inverses of each other, so this will be x times x times x times x. Well, that's x to the 4th. Now I think about that absolute value bar piece. So here's what I'm checking. Is the index even? Because if the index is even, I might need absolute value bars. Yep, that was a 2. Okay, the index was even. Is my answer raised to an odd power? I don't need absolute value bars because this will guarantee that this is going to be positive. So when they wrote this problem, notice it was x to the 8th. No matter what we put in for x to the 8th, we were guaranteed this was going to be positive and it was something that we could do. In our answer, we are still guaranteed this is positive, it's going to be something that we can do. So why do we do that? Because we must have the same domain that they began with. That means if somebody's writing a problem, they are thinking in advance about what numbers you could use in that formula. And we need to keep that all the way through the problem, even when we simplify it. So let's go to B. Cube root. Okay. I need the cube root of a to the 6th, and I need the cube root of b to the 9th. Notice how I'm just separating those, so I'm just working with the a's and just working with the b's. Well, now I'd want to break them up into groups of 3. So the cube root and cube are canceling each other out. So cube root of a to the 3rd, cube root of a to the 3rd, 3 and 3 makes 6. Got it. B to the 9th, I'm going to need cube root of b to the 3rd, cube root of b to the 3rd, cube root of b to the 3rd, 3, 3, 3, 9 of them. All right. Well, this is A. This is A. This is B. This is B. And this is B. A squared, b to the 3rd. Last step. Do we need absolute value bars? Do we have an even root? None. No absolute value bars. It's only when you have an even root and you have odd power answers that you have to use those absolute value bars. We don't need it. Let's look at C. 4th root, x to the 8th, y to the 12th. Good. I looked out and people are all ready. I'm going to do this one. I already know how to do this. 4th root of x to the 4th, 4th root of x to the 4th, 4th root, y to the 4th, 4th root, y to the 4th, 4th root, y to the 4th. That gives us our x to the 8th because when we add those exponents, they equal 8, and y to the 12th. So this will be x times y times y. Okay, x squared y to the third. Well, we better think about absolute value bars because this was fourth root. So when they started, take a look at this. No matter what we had put in for x and y, we were going to be able to do this problem because it was going to pop it out positive. Is there any chance that anything down here in our answer might end up negative? Which one? It gets the absolute value bars. Exactly. Now, it's great if you just learn the rule. If you have an even index and you get an odd power for an answer, you slap the absolute value bars. That's great. But what we're going for is your understanding that when the person wrote this problem, these are the numbers they wanted us to use. And we have to make sure that when they see our simplified answer, people are going to use the same numbers. And that's where we get this absolute value piece. So with your partner, A, B, and C, those are yours. Take a peek. See what you can do. That is what?
9.
And what did you get when you took the square root of x squared times the square root of x squared?
X squared.
Did that require absolute value bars?
No.
Even index, even power. It's even index, odd power that we're concerned with because that would make this negative piece come out of this problem. And that was not intended originally. Everything was supposed to be positive. So we have to make sure that happens. And it is going to happen in this problem because it's going to be squared. So then we get to B. And I heard people say it. This one takes a long time to write out. Yes, it does. But we get a to the third. 1, 2, 3, 4, 5 B's. And that's when you start to think, is this kind of the long way? Is there a shorter way to do this? What's the shorter way? Dividing. Using the index
So
to divide. Oh, thank you. I thought I had 1, 2, 3. Oh, well, I shorted myself. Thank you. So why on earth am I having you do this writing out thing when all the problems we did in class worked out perfect? Not all of them. Remember my really basic example up here? The square root of x to the 5th. We're starting off with the really nice ones. Later on, not so nice. So does the division thing still work? It does, but you're going to get remainders. And ugly remainders have to stay underneath the ugly radical symbol. So the nice stuff, 2 does go into 5, it goes in there twice, but it's not perfect. It has an ugly remainder. That ugly remainder is going to be the square root of x. Ugly stuff under the ugly radical symbol. So this process works every time. It doesn't matter if it's something nice and perfect or if it's something ugly. This is going to work. But so does division, as long as you can remember. Any ugly remainders? Under the ugly radical symbol. They have to be. So when we get to this, oh, I forgot B. Should we use absolute value for B?
No.
Why not?
It's 5.
Odd root. Don't need it. All right, so now you look at C. Think of the division. 4 goes into 12 3 times. 4 goes into 16 4 times. Again, almost a little too nice. Everything works out perfect. Does this one require absolute value?
Yes.
Yeah.
Yes.
For both of them?
No.
Which one?
Yes.
Beautiful. That one right there. That's where we're going to need it. So it's a little more involved when we get into variables. You just have to keep your head about you and say, this is not a big deal. I can do this.
It's not a big deal. I can do this.
There you go. Give yourself a little pep talk. Do one of these. I'm good. All right, academics. Some teachers, not in our math department, adjust test scores when the test is difficult. One teacher's formula for adjusting the scores is A equals 10 square roots of R. where A is the adjusted score and R is the raw score. Now the raw score is the score the students had. And then they plug that in there and they get this adjusted score. So it says if the raw scores on one test ranged from 36 to 90. So they didn't have anybody get higher than 90 and they thought, hey, we'll curve this. How am I going to curve this? And this was their formula. What is the range of the adjusted scores? Well, if the lowest score was 36, we need to find the lowest adjusted score. So that'll be 10 times the square root of 36. Again, I didn't have to come up with that square root to solve it. It was in the problem. That means we're only looking at positives, and because it's test scores, I really hope nobody could get a negative test score, but there we go. So order of operations, square root of 36 would be 6 times 10.
60.
So now the lowest score is a 60. Oh, boy, it was a 36%. Now it's a 60. Eesh. Highest score. 10 square root of 90. It's the square root of 90. Something not nice. Let's grab a calculator. See what I do. Did anybody want to say 30 right away? That's 900. So, square root of 90. Let's see, that's that. We move the decimal place over one spot when we multiply by 10. So, about 94.9. So now at least they could say, somebody could get an A. 94.9. I mean, if I adjust these scores, now I have somebody that can get an A on this test. So, we would finish this up since it was a question. What is the range of the adjusted scores? The adjusted scores are from 60 to 94.9. Those were adjusted scores. If you wanted to write it mathematically, you could say, well, my adjusted scores are between 60. And notice how I'm not putting an equals bar under there, and that's because some people would argue because we had to round to get that, we really shouldn't put an equals bar there, but let's not be picky. Say, yeah, we'll just call it 94.95. So for you and your partner, what if somebody skipped on the day of the test? They got a 0. They are now the new low score. And somebody in the class managed a perfect paper.
Cheated.
It's a tough test. You might have. Took a picture of somebody's completed test. I don't know. But find the new adjusted scores. What would they be? And then find your partner. So with that, we've got our 0 to 100. Now, what I need from you is a 4, 3, 2, 1, 0. How you feel about, I would say, just give me what you felt about the toughest thing we did today, which was those absolute value bar pieces with the variables. Give me a 4, 3, 2, 1, 0. Good. I like to see the confidence. Hey, thank your partner for their wonderful help. You guys did a great job.
That's funny enough.
Oh.
I do.
Here's the deal. Your book really doesn't give you enough examples of the variable stuff that we did. So don't be afraid when you see this worksheet. We're not doing the whole thing. Nobody needs to cower in the corner in the fetal position. Let's not do that. We're not going to do the whole thing.
I just see the whole stuff.
Nope, sorry, Justin. Got some word problems in there that are going to be important.
Well, I'm probably do that. Can we make it even?
No.
Thanks, Joey. Yeah. You get a sample.
So what do you need? Once you get this written down, I'm going to ask you about some of these and see if you think you need any more practice on them. If you don't, you don't. If you do. It's a lot of problems. Ready? Oops, nope, some people are still writing. All right, grab the worksheet.
Oh, yeah.
From what I saw, it didn't look like you needed any more practice with 1 through 20. Do you feel you need more practice with those?
No.
Okay. So we do need some more of these simplify each. What do we have so far? 1, 2, 3. How about we do the evens down there?
Just 21.
22 to 32, the evens.
Oh. Alright. That's it?
Well, there's some other stuff on here. So it's the solving stuff. 35 through 42, hang on though. I don't think I want you to do it 35 or 36 or 37. Those are, well, 37 has a decimal in it. So let's do 37 to 42.
Oh.
That'll be it, because there's some nice word problems in this stuff. So we've got 22 to 32, the evens, and then 37 to 42.
First one's 11. Why did
Shh. Thank you. Anybody that remembered a home and school communication form, I'll be walking around to see if anybody needs help. You can just hand that off to me when I come around, if you haven't already given it to me.
it's the blue flies? Better check the back of the book, make sure we're right. Absolute value, like, it's the 11. Yeah.
11 is 11. Now we know what it is. So we know we have to see that side. Because we're not sure what people are going to do for that. That's why we
Oh, this one's not so nice.
Don't forget to keep that power chart handy.
Yeah.
It's going to help you out a lot to use that instead of grabbing the GC.
Power. Oh, see.
Okay, anybody?
It just takes a while.
Whatever the setting.
recording the whole time?